Hi, good morning everyone. I think it's good noon already, exactly 12 o'clock. So, I come from the semiconductor technology background and I will get you through a quick trends as what is that semiconductor technology could enable into the smart grid aspects. Particularly when we look at any business, there are two things which are very, very important in order of the return of investment. One is how can we increase the revenue model, and second is how can I do the cost reduction. And there is no charity. Finally, the return of investment becomes very, very important actually. So the communication, which is very, very important actually in this world, you might have heard the concept of Internet of Things. People expect more than 50 billion devices will get connected. Most of these devices will be personal gadgets or sitting inside the home and somewhere actually. So communication is critical. And there are a lot of communication technologies available. Some of them I just put it on the chart right now. But there is no dearth of that. A lot of standards, a lot of things are available. And the key thing here is to how do we pick and choose some of them to make the overall network much more cost effective. Looking at two axes of revenue increase as well as cost reduction. The first and foremost very important thing is we should always look at the global standards. Whatever is already standardized and it is accepted everywhere, just pick and choose and put together the network so that it becomes easy to achieve the interoperability. If there is no interoperability, then things are getting stuck somewhere. We are looking at this as a machine-to-machine model, which is more of going to remain in the field for 10 years, 15 years, 20 years, you don't know. And that's why this interoperability becomes very, very important actually. Not only interoperability, the platform approach, because when the hardware and the software is sitting in the field, if you want to do bug fixing, you want to provide the upgrades, whether there is an architecture which is being defined accordingly, so that the maintenance and field improvements and all other things becomes very, very easy. That also need to be looked into. And that's what is the future readiness. And the most important thing is the end-to-end system, where you can pick and choose multiple technologies in an interoperable way, build a platform concept, but finally achieving the complete end-to-end system, which will be much more cost-effective and providing the complete return of investment while keeping the reliability in view. Because once again, once the deployment of the infrastructure is done, you cannot expect that every day somebody is going and repairing and maintaining those things actually. So that's pretty critical actually. I skipped this one. We already had a comparison of the 2.4G versus sub-G. I don't think I want to get into that debate at this moment, right, at this stage. There are various markets which we need to look into from the smart grid concept, and it is not only the smart energy, which we are talking about here, the smart metering concepts, but also the various things like consumer and lighting, home building automations, asset tagging. Many things will come together. As I mentioned, as the Internet of Things, many things will get connected. And we need to be aware of all those things. Those are in future getting connected somewhere onto the grid actually. So it's not only smart metering, but I think it's an entire gambit which is need to be covered. There are two aspects to it. One is what can be done in real time and what can be done as a multi-service. And I don't think right now everybody is looking into that aspect actually. We are looking at right now more of a real-time scenario where you collect the energy maybe at a smart metering concept and put it back onto the grid, onto the back end. But what we have to look at is more of a future, more of multi-service concept where you have the radio, you have the communication device, and you have various other stuff already installed, hardware and software, how it will enable the cloud computing, and then multiple services could be deployed over and above on top of that actually. This is a very simplified view of network, which could be feasible in a country like India, where you have the various houses connected through a Zigbee network with a mesh and network established. And multiple of those things would be connected to a DCU. And from there, you can bring it either by a GPRS, GSM modem, or some other way, getting into the data center, IP network, and other stuff. Looks simplified. Obviously, there are a lot of complicated things to be implemented over there. But again, as I mentioned, we have to look at what could be much more cost-effective way to implement, keeping in view the global standards, interoperability issues, and future upgrades, which are definitely possible with this kind of approach where you use multiple technologies and really put together an entire network. Not going through detail, just an example how the technology is evolving. So you have the smart metering things, and where now the things were more of electromechanical meters in past went to electronic meters, and now you have the electronic meter plus the RF, which is put in together, two blocks. Going forward, this will become a single block, and then you will keep adding more and more hardware and software stuff actually. And this is where the semiconductor really plays a role. The technology is advancing very fast. It provides the opportunity of more and more processing, more and more open architecture, as well as providing more cost reduction possibilities going forward in the future. And that's where the technology is really advancing very, very fast. Zigbee 2.4G is what has been already been accepted in many countries worldwide. There are some projects going on in India as well, including MSCB and Reliance. They are doing something. And that's what we see as one of the really key technology which will enable this connected things or connected Internet of the Things going forward, along with various other technologies. Those will work together. So I'll skip some of those in view of time. One example I just mentioned was you integrate the single chip metering architecture and the radio put together, and then finally it will evolve as a single chip device doing a lot of real-time stuff, as well as the cloud computing and other stuff going forward in future. Some simple examples of how some devices will take shape. So this is an example of a smart plug where you put as a load control, and through Zigbee it will communicate, and then the network and a lot of energy audit and monitoring could be possible. And you can display onto the screen, either onto the phone or a TV or a computer or maybe a simple device. You can also expect some USB dongles coming in forward in future so that you connect to your computer or a laptop. And there is a standalone device which can be put onto the table. And you can do the billing, non-billing kind of a metering. Currently you look at only as a billing meter. In future you will always certainly see a non-billing meter also which will be involved. Then you will have the remote controls, which are most of the time you see always are the infrared, getting into again 2.4G domain, and lighting control and so many things. So there's a quick overview. As I mentioned, the key thing here is to pick and choose the technology, build the interoperable using the global standards, keep it of future readiness, and really look at the return of investment from two axes. One is revenue increase, another is a cost reduction. Thank you.